Today we're going to be talking about absolute value. So let's start by defining it. The absolute value of a number is its distance from zero. The way that we can represent that are using absolute value bars, which is just a straight line. The number that you're talking about, I'm going to use x for right now, and then another straight line to end it. So those are called your absolute value bars. When you see something like that, where you have the absolute value bars and a number inside, you would read it as the absolute value of x. X could be any real number in there, like 1, 2, 3, -1, -2, -3, any sort of decimal or fraction. So just to get kind of a visual of what absolute value would look like, if you wanted to see the absolute value of -4 equals 4, you would have a model that started at 0 and went all the way to -4. This model would be showing that the absolute value of -4 equals 4. So how far is -4 from 0? If we were to count all of these spaces, we would have 1, 2, 3, and 4. So that's 4 units away. In the opposite direction, if we wanted to find or to make a model for the absolute value of 4, we would start again at 0, but this time we would go to the number 4. So we'd be going to the right. So this is showing the absolute value of 4 equals 4. And again, we would want to count the distance from 0. So 4, if we start back at 4 and go to 0, that's 1, 2, 3, 4. So 4 is 4 units away from 0 as well. That helps us figure out that the absolute value of -4 equals 4, but so does the absolute value of 4. They're both equal to 4 there. So absolute value is just the distance of a number from 0. At the bottom of this page we have a few examples for you to try. So for the absolute value of -34, think about on a number line, how far would -34 be away from 0? If you were to count all those spaces, you'd be 34 spaces away. Go ahead and try the rest of these examples on your own. So pause the video, and then when you're done trying it, check your answers by pressing play. Now that you've tried them on your own, let's talk about what the answers are. In our next example, we had the absolute value of 12. 12 would be 12 units away from 0, so the answer there is 12. This next one was a little bit different. You had to figure out what could go inside of the absolute value bars that would equal 23. Well, the number 23 would be 23 units from 0, but so would the number -23. So either of these answers here could work for x in this certain equation. Moving on to the next one, we could see it the same way. So we have the absolute value of x equals 13.7. So either the number 13.7 would be 13.7 units from 0, or so would its negative, or its opposite. So these are both correct answers for what we could have in our absolute value bars for x here. Moving on to our next one, we have the absolute value of -0.245. Even though it's a decimal, it's still the same concept. It would be 0.245 units from 0. So we just want to have that positive number there. In this last example, we have the absolute value of 2.5. So again, with the decimals, it would still be 2.5 spaces from 0. So as we move into a few other examples, this says if there is a negative sign in front of the absolute value bars, then your answer will be negative. So in front of the absolute value bars just means to the left of them, because we read from left to right. So in this first example, we've got the opposite of the absolute value of -19. So that negative sign on the outside of the absolute value bars is going to come right to the front of our answer on the other side of our equation. And then we're going to look at what's inside the absolute value bars. So the absolute value bar, or the absolute value of -19 is just 19. So that means we brought our negative sign over, and then our answer from inside the absolute value bars is 19, but this final answer here for this entire equation would be -19. So go ahead and try the next two on your own. Pause the video and then check your answers. Okay, hopefully you tried them on your own. Let's check to make sure we did them correctly. So the first thing that we notice on the left is that negative sign, so we're going to bring that right over to our answer. And then we do what's inside of our absolute value bars. So the absolute value of negative 6 is just 6. So that means that we're going to bring our 6 over here, and our answer is negative 6. So the negative absolute value of negative 6 is negative 6. This last one, we have the opposite of the absolute value of 1/2. So start by bringing your negative sign over, and then the absolute value of 1/2 is just 1/2. So we have negative 1/2 as our answer. In the next section, it says if there is an operation inside the absolute value bars, these are the steps that you need to complete. You first want to complete the operation, and then you want to take the absolute value. So that's the order that we're going to follow here. So looking at this first example, we notice that we have the absolute value of 19 plus 12, and that's where the absolute value bars end. So that addition sign is inside the absolute value bars. So that's what I was talking about right up here. So we first want to complete the operation. That's our step 1. So 19 plus 12, we know that's 31, but we still need to take the absolute value of that. So that's our next step. Number 2 says take the absolute value, and we know that the absolute value of 31 would just be 31. So 31 is our final answer here. As we look into the next one, we have a subtraction problem. We have the absolute value of 3 minus 6. So this subtraction sign is inside the absolute value bars again, so we want to do that first. So 3 minus 6, that's negative 3. But we still haven't taken the absolute value, so those absolute value bars need to go around there. Step 2 says take the absolute value. The absolute value of negative 3 would just give us 3, so our answer here is 3. Sometimes the operation will be outside the absolute value bars. We just looked at what happens on the inside, but if it's outside, the steps are just reversed. So you first want to take the absolute value, and then you will complete the operation. So if we look at this first example together, it has the absolute value of 22, close the absolute value bars, plus the absolute value of negative 113, and then you close the absolute value bars again. So notice now this plus sign is on the outside of these absolute value bars. That means we want to take the absolute value of negative 22, which is 22, and then we're going to find the absolute value of negative 113, which is just 113, and then we will add them, because our step 2 says complete the operation. So when we add these up, we get 135, and that is our answer for this problem. So moving on to this next example, we have an operation inside the absolute value bars and one that's outside. So we first want to do what's inside first. So we start with 15 minus 15. That's going to give us 0, but we still haven't taken the absolute value of that yet. Then we need to add 8 to it. The absolute value of 0 is 0, and we're going to take that first because now the operation is on the outside of the bars. Then we're going to add 8, and 0 plus 8 just gets us 8. And there's our final answer.